It was a sports day. The students of the Shining Future School were very excited. Ronit sir was explaining the duties to the student volunteers. The principal began the event with a short speech. The kids took part in the spoon and lemon race, followed by the sack race. After that, it was time for the orange race. Ronit sir was explaining the rules to the participants.
There will be 5 rounds of the orange race, 10 participants in each. 2 participants from each round will be selected for the final round. In this race, a basket will be placed at the starting point, which is 7 meters from the first orange. The other oranges are placed at a distance of 5 meters. Overall, there are 10 oranges. Each participant of this race starts from the basket and picks up the nearest orange and runs back to the bucket to drop the orange in it. He runs back to pick up the next orange and drops it again in the basket. The process continues. A student has to pick the oranges one by one. The one who covers the maximum distance has to be selected for the final round.
Susan was given the task to calculate the distance covered by each student in 1 minute. She did it in few minutes. After the final round was over, Ronit sir checked the calculations.
Susan, I think you have counted the oranges to guess the maximum distance. But you should have used arithmetic progressions.
I counted a number of oranges. But what is arithmetic progression and how to use it here?
And that brings us to the very first session on arithmetic progression. Hello friends, welcome back to Notebook. Friends, how would you have calculated the distance run by each student in the orange race? Before we discuss that, let me introduce you to a famous mathematician, Carl Friedrich Gauss. In 1780 AD, a German schoolmaster gave the task of adding the first 100 natural numbers to the students to keep them quiet. He thought the students will remain busy with the task for at least 1 hour. But one of the students solved this question within a couple of minutes. He didn't memorize the value. Then, how did he solve the question? Can you guess? See, if you arrange the first 50 numbers in a row and the next 50 numbers in the reverse order in the next row and add them column-wise, you shall get 101 each time. The number of times we get this result is 50. So the sum is 50 into 101, that is 5050. Don't you find it easy? We shall talk about many such stories, but before that, let us understand what an arithmetic progression is. Consider the list of numbers 1, 2, 3, 4 and so on. Yes, of course, these are the natural numbers. But see that the difference between any 2 consecutive numbers of this list is 1. Consider another list of numbers, -2, -4, -6, -8, -10 and so on. The difference between any 2 consecutive numbers of the given list of numbers is -2. What about this list of numbers? 5, 5, 5, 5, 5, 5. What is the difference between any 2 consecutive numbers of this list? See friends, it's 0. Friends, remember that each number of the list is known as a term. Well, each of these examples represents an arithmetic progression. In fact, an arithmetic progression may be defined as a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. The fixed number is known as the common difference. As clear for these examples, the common difference may be positive, negative, or 0. Friends, an arithmetic progression is abbreviated as AP. So we shall use this abbreviation for the sake of simplicity. Now that you have understood AP, let's define it using expressions and variables. In general, we may denote an AP by A1, A2, A3 up to AN. That means A1 is the first term, A2 is the second term, and likewise AN is the nth term. Suppose we denote the common difference by D, which means A2 minus A1 is equal to D, A3 minus A2 is also equal to D, A4 minus A3 is equal to D, so on. AN minus AN minus 1 is also equal to D. A2 minus A1 is equal to D. This implies that A2 is equal to A1 plus D. Similarly, A3 is equal to A2 plus D. Replace A2 with its value, we see A3 is equal to A1 plus D, that is A1 plus 2D. In a similar manner, we can derive that A4 is equal to A1 plus 3D, A5 is equal to A1 plus 4D, and this goes on. We can generalize this as AN is equal to A1 plus N minus 1 whole into D. Students, now I will show you a list of numbers and you have to compute the nth term. Don't worry, I'll help you. Take a look at this list of numbers 3, 5, 7, 9. Friends, can you find its 35th term? Observe that the first term is 3, so A1 is equal to 3. Since we need to calculate the 35th term, so n is equal to 35. What about the common difference? See, 5 minus 3 is equal to 7 minus 5 is equal to 9 minus 7 is 2. Each time the difference is 2, so d is equal to 2. Now recall the formula an is equal to a1 plus whole of n minus 1 into d. Therefore, the 35th term denoted by a35 is 3 plus whole of 35 minus 1 into 2 is equal to 71. Friends, this shows that we can calculate the nth term of a series using the first term and the common difference. Friends, I think that is enough for this session. Now, your task is to find any 5 real-life situations representing an AP. We shall be back soon with the next session to discuss the real-life concepts as well as the mathematical relations based on AP. Till then, keep learning and take care.